All right, hello everybody. Welcome to lesson 6 of our chemistry unit. Last time we talked about the structure of the atom, and I did show you a diagram that looked like this. So today we're going to learn how to make these. And the idea comes from figuring out how many protons and neutrons and electrons are there in an atom using the chemical symbol on the periodic table, so what we did last time. Then using that information, we're going to create a model of elements that looks like this. So as you're watching this video, or maybe you're reading through the slides, your instructions are to write a note. Again, I've created a Google Doc if you want to use this as a template. So if you take a look here, again, this is posted in Brightspace and it should be called Lesson 6 Bohr-Rutherford Diagram Note or something like that. So if you want, you can print this off and then fill it in as we go along, or you can just write your notes in a notebook or something like that. Okay, so back to the lesson. So Bohr-Rutherford diagrams, well, just a little bit of a history before we get to figuring out how we build these. Scientists Bohr and Rutherford independently discovered that electrons of an atom arrange themselves in energy shells, or they look like orbits around the nucleus. And each of these cells has a maximum number of electrons that it can hold. And these diagrams are used in chemistry to create visual representations of atoms. And as you go on in chemistry, they help you learn how compounds are formed with two or more elements. But today we're just going to focus on making these diagrams. So this is a very important thing to know. In each shell, there's a maximum number of electrons. So E minus is just shorthand for electrons. In the first shell, we can only have up to 2 electrons. So once you get to 3, you need to add another shell. So in the second shell, we can have 8. In the third shell, we can have another 8. And then in the fourth shell, we can have 18. And yes, we can go higher than that, but for this class, we're just going to worry about the 4 inner shells. So here's an example of a Bohr-Rutherford diagram that I showed you last time. So in the center, we have 6 protons and 6 neutrons. So you can definitely draw them like this, but I'm going to show you a short way to do it. And then we have also 6 electrons. Notice how the first shell, there's only 2. And in the second shell, then we put our next 4. And yes, there is kind of an appropriate way to where these electrons are located. I'm going to show you that as well. Okay, so here are the basic steps to doing a diagram, and then we're going to go through one. So first you're going to draw a circle to represent the nucleus, and then inside that circle you're going to write the element symbol, the number of protons, and the number of neutrons. And if you want, you can say P plus equals whatever the number is for protons, and N0, because 0 means no charge, equals however many protons. And then you're going to draw circles around the nucleus to represent the electron shells. And you're going to draw 1 dot for each electron. Now you're always going to draw the electrons by filling the clock. You're going to start at the 12 position first, then 3, then 6, then 9. And then if there can be more electrons, or there needs to be more, you're going to start pairing them again. So 12, 3, 6, 9. Once an orbital or shell has reached its full capacity, you have to add another orbital or shell until we have all the electrons. So let's do an example. So let's see, we have sodium here, and here is our atomic representation of it. So sodium its symbol is Na. Down here, remember that's the atomic number, and that tells us the number of protons and electrons. And the number of neutrons we get by subtracting the mass number and then the atomic number. So 23 minus 11 gets us 12. So that's how many things of each. And now we're going to use this information here to make our Bohr-Rutherford diagram. So our first step is to draw a circle for the nucleus. And then our second step is to put in the symbol of the element, number of protons, and number of neutrons. So protons was 11, neutrons is 12. And now we're going to add our electrons. And because electrons has the same number of protons, I have to put 11 of them. So I'm going to add a circle for the first orbit or the first shell. Now this one could only hold 2 electrons. So we're going to put one at the top, and then you could put one here. That's not wrong, but I like to have them balanced, so I'm going to put one on the bottom. Now this shell is full, so now we have to add another shell. Now this one can hold 8, remember. So we have 2 here. So we're going to start at the 12 o'clock position and then go around the clock. So we got 1, 2, 3, 4, 5, 6. And now remember, we're going to pair them up here. So 6, 7, 8, 9, 10. Okay, this shell is now full because it has 8 electrons on it, which means we have to add another orbit or shell. And we only need to add one more because we already have 10 electrons. And so there's our 11th. And there is our diagram. So I want you to try this. I want you to draw the Bohr-Rutherford diagram for the first 20 elements. On the next slide, I do have the answers, and I'll also post the answers separately in Brightspace if you want to check that out. Okay, so here are the answers. This is mine, so I apologize. There's not a lot of room, but you should be able to check it. You'll start noticing patterns though. For example, down the columns, you'll see they all have the same number of electrons in the last shell. So for example, 1, 1, 1, 1. And then through the rows, you'll notice they'll have the same number of orbitals or shells. So that's it for today. If you have any questions, please let me know through Brightspace. And otherwise, I'll see you next time. Bye-bye.